Yes, hello. It's nice to see you, class. So, today we're going to talk about chemical bonds. So, what happens when atoms combine together, whether into small groups or very large ones? I want to start this off with a common thing about chemical bonding. Like charges repel, opposites attract. So, if a chemical has a positive charge, it's going to repel away from another chemical that's positively charged, and also, but if one chemical is positive and the other is negative, those opposites are going to attract. So, yeah, that's important to remember and realize. So probably the best known atomic scenario is between sodium and chlorine because it produces NaCl, table salt. Essentially, sodium has one electron in its outermost shell that is very weakly attracted to the nucleus. Its electron is called 3s, which tells us something about electron orbitals. Basically, the inner shell is 1s, whereas the next two shells are 2s and 2p. Then it goes to 3s, 3p, and 3d. But something important to remember here is sodium's 3s electron, there's only one electron there, and it's very weakly connected to the nucleus, which is equal in electric charge to the charge of the electrons. So you have to remember that nucleus is positively charged and the electrons are negatively charged, but this one electron is further out from the nucleus than the rest of the electrons, so it's very weakly connected to its nucleus. So chlorine, though, is its electron configuration is labeled as 3s2, 3p5 arrangement in its electrons because it's so 3s2 and 3p5. So all its electrons are in the third atomic orbital, and since they're all in that third orbital, they are more closely attracted to the nucleus that is, again, equal in charge to the electrons. So the nucleus in chlorine is much more strongly attracted to the electrons in the 3 shell than its sodium. That's something to remember. You should all remember that. So the electrons from sodium's weak 3 shell is more strongly attracted. The electron from sodium's weak 3 shell is much more weakly attracted to the nucleus when there is a chlorine atom nearby. So as a result, sodium has a more positively charged atom than chlorine. So basically, since sodium's electron is very weakly connected to its nucleus, the electron leaves the atom in a much easier way than would, say, the chlorine's electrons. And so to be attracted to because of this, the electron is much more easily attracted to the chlorine's nucleus, and so the sodium has what we call a positive charge because, of course, the nucleus has one more proton than it has an electron, and of course, in the chlorine atom, it's negatively charged since its outer shell contains an electron, which means it has more electrons than protons in its nucleus. So, as a result, sodium has a positively charged atom and chlorine has a negatively charged atom. So, the atoms bond together due to this electric sort of attraction. Positively charged sodium, negatively charged chlorine, they combine together. Important to realize. Yes, so covalent bonds. Okay, so if there are But if the electrons are attracted only by ions of opposite charges, how come molecules like H2 and Cl2 exist? I mean, do keep this in mind, because H2, there's a positively charged ion and another positively charged ion, and yet somehow they're attracted to each other. The same thing with chlorine. Negatively charged atom, another negatively charged atom, they're attracted, and why is that? So electron sharing is an answer. Electron sharing. Essentially, when two of the same atoms often come together, these atoms often want another electron in its shell. They want the other electron in its shell, but why would a positively charged hydrogen be attracted to another positively charged ion? So look at hydrogen. It has one electron in its 1s shell, but the 1s shell wants two electrons. The shell wants two electrons, but not the atom in general. So it can get that electron from another hydrogen that also wants another electron. So yeah, two atoms of hydrogen, they both want another electron in its outer shell. So how do they get that electron? So how do they get that electron? Well, they share them. Basically, two electrons are shared in the inner shell, being attracted to the two nuclei. So two positively charged nuclei in addition to the two negatively charged electrons. That attraction works. So chlorine works in a similar way. Both atoms want the 8 electrons in their outermost shell, but they only have 7 electrons. So they share that desire by having them bond to one another. So yeah, but this bond has them sharing only 14 electrons in the outermost shell. 14 out of the 16 they need to have a full shell. So why is this? It's due to a really strange thing in chemistry, that even numbers are more wanted than odd numbers when it comes to electrons. So consider what the electrons are. So you remember the 1s shell only has 2 electrons. There's only 2 electrons. So then why does the p shell have 6? Why? The answer is due to the fact that there are 3 subshells within that p shell. There's the 2pz shell, there's the 2px shell, and the 2py shell. And because of this arrangement, the even numbers are much more wanted than the odd numbers. So do consider that so it'd be much more preferable to have an even number of electrons than an odd number, because then, for instance, if we only had 14 electrons, 2pz and 2px could be filled, but 2py could be absent. Whereas you wouldn't want 2pz, 2px, and 2py half filled. That's not very favorable. So, chlorine is a non-polar covalent bond. So, yeah, because, of course, chlorine has a negative charge and there are 2 chlorine atoms together, how are they attracted to one another? It's that arrangement. So, then, though, why don't we go to polar covalent bonds? Because let's talk about polar covalent bonds for a bit. Probably the most famous example of a polar covalent bond is the fact that oxygen has a -2 charge, and the hydrogens each have a positive charge. So if we have positively charged hydrogen and another positively charged hydrogen, we have 2 hydrogens filling the electron want for the oxygen's 2 negative electrons. Filling the oxygen's desire, oxygen wants 2 electrons to fulfill it, and so it gets these 2 electrons from 2 hydrogens. So, but then, let's talk. It's not just water that has this arrangement. What also has this arrangement is hydrogen chloride, because you consider it's HCl. So hydrogen has one electron, and chlorine is missing one electron and wants one more. So to get this, it just is with another hydrogen, so HCl. And methane works a similar way, CH4. You basically have carbon, which it wants 4 electrons, and it will borrow those 4 electrons with 4 hydrogen atoms. So hydrogen, 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 carbon. So consider that carbon needs 4 electrons, so it shares them with the hydrogens. And ammonia is similar too, NH3. So the ammonia is NH3, so it wants 3 electrons, because remember it's number 7 on the periodic table, so it wants 3 electrons, and it borrows those with 3 hydrogen atoms, so NH3. And that explains how chemical bonds work, or at least as much as I'm going to explain to you today. So yeah,